Our assessments consisted of testing 24 subjects from our class. Of those 24 subjects, 8 were male and 16 were female, with an average of 20 years. When looking at athletic involvement, only 30% are still active into the college level. According to the American College of Sports Medicine, aerobic exercise should be conducted 3 to 5 days per week with 30 to 60 minutes per day, or a minimum of 1.5 hours per week. All of our subjects seem to place the minimum recommendation or higher. For strength exercise concerning both muscular strength and endurance, the ACSM recommends 2 to 3 days per week with no specific time duration. 21% of our subjects admitted to 0 hours of involvement. Strength exercise involvement was difficult to compare to the recommendation because subjects' involvement was measured in hours, not days, but 79% of subjects do participate in some form of strength exercises. 2 areas of fitness we chose to assess were cardiorespiratory fitness by a YMCA pre-established step test and globe jump station, and muscular endurance by a 2-trial wall sit station. Cardiorespiratory fitness is the ability to perform dynamic exercises involving large muscle groups at moderate to high intensity for prolonged periods of time. Muscular endurance measures the ability of a muscle group to exert submaximal force for an extended period of time. Our pre-established test was the step test, which was administered to follow the YMCA's 3-minute step test protocol. Participants followed a metronome with a cadence set to 96 beats per minute. After the 3-minute duration, recovery heart rate was measured for 30 seconds. The YMCA protocol states to measure it for a full minute, and this is one source of error we had. We developed the second test, which was created to measure cardiorespiratory fitness. We had specific directions on how to perform the test, but we were surprised to see so much variation with each individual. Some participants weren't able to follow the form correctly, while others fully exerted themselves. We learned that in order to get more valid results, a test that was an easier protocol to follow would be better. As we chose the YMCA step test and globe jumps to measure cardiorespiratory fitness, we believed that we would see a correlation between the two because they are both measuring the same type of fitness, and therefore subjects would record similar values for recovery heart rate. We chose wall sits as a 2-trial test because we wanted a test that was both easy to participate in and would produce reliable results. Furthermore, we were hoping to prove that a more efficient recovery heart rate response to cardiorespiratory fitness would correlate with a longer duration wall sit or a larger capacity for muscular endurance.
We analyzed the mean, median, mode, and standard deviation for all 3 tests. The mean is the average score, the median is the middle score, the mode is the most frequent score, the standard deviation describes the scatter of scores around the mean. These are the results for all 3 tests. Here is a frequency distribution table for the wall sit test. A frequency distribution table allows us to see how many people fall into a certain interval of scores. This table shows that most of the participants fall into the categories that represent a shorter time. This table highlights the highest and lowest scores we had as well as the scores closest to the mean. A z-score is used to tell how an individual score compares to the overall mean. A z-score of 0 means that the score is closer to the mean. The highest score was 144 beats per minute. This was a z-score of negative 2.0178, which means that it was 2 standard deviations below the mean. The lowest score was 76 beats per minute, which had a z-score of 1.4780. This means it was 1 standard deviation above the mean. The individual with the score of 104 beats per minute had a z-score of 0.0386. Because the z-score is so close to 0, we can conclude that this score was the closest to the mean. This table highlights the highest and lowest scores as well as the score closest to the mean. A t-score expresses how far away a number is from the mean. A t-score closer to 50 represents a score that is closer to the mean. The highest score we had was 158 beats per minute, which had a t-score of 35.8018. Because the t-score was lower than 50, we can conclude that the score is significantly worse than the mean. The lowest score we had was 108 beats per minute, which had a t-score of 72.8406. This shows that the individual has a significantly better score than the mean, indicating better cardiovascular fitness. The individual with a value of 138 beats per minute has a t-score of 50.6173, meaning that they had a score closest to the mean.
The Pearson product moment correlation shows a relationship for 2 variables. In this case, we are comparing the results between a step test, which was measured through heart rate, to the results of the wall sit test, which was measured based on time. The correlation between the 2 tests was negative 0.2. This represents a low negative correlation. In other words, this correlation demonstrates that subjects who performed better on the step test, which was represented by a lower heart rate, generally performed well on the Walsett test, which is represented by a greater time. The scatterplot graph shown illustrates this correlation. The linear regression formula was y equals 0.27x plus 110. The results that we collected from the tests were what we expected, since there have been research studies that suggest that lower limb muscular strength has some effect on cardiorespiratory fitness, with a positive correlation. A possible source of error that could have affected the results is the fatigue the subjects may have been experiencing due to the multiple muscular endurance tests they performed the day of testing. We used the Spearman-Rowe correlation to show the relationship between the step test and the globe jump test. This was calculated by ranking each subject in the tests and determining if there is a correlation between the rankings. The equation used to determine the correlation coefficient is shown here. The correlation coefficient for these tests was negative 0.11, which shows no correlation. Since both tests measured cardiorespiratory fitness and both tests were measured through heart rate, we expected our results to have a moderate to high correlation. Since the results we obtained were not what was expected, we analyzed any complications that may have affected the results. While observing the subjects participating in the globe jump test, we noticed it was difficult to control how the subjects performed the exercise. For example, some students were jumping very high off the ground, while some were only jumping a few inches off the ground. Also, some subjects were raising their knees high to their chest, while others had difficulty doing so. Also, it is possible that some subjects had greater motivation to perform the exercise to the best of their ability. Let's use one subject as an example. Referencing to the table below, we can see that this subject ranked first of the group for the step test, but ranked second to last on the globe jump test. Since this subject was ranked with the best cardiorespiratory fitness among the group that was tested in the step test, it is possible that this subject was more familiar with cardiorespiratory exercise. If so, it is possible that this subject would have a greater motivation to complete the globe jump test in maximal effort, in turn raising their heart rate over the other subjects. Of course, the level of motivation for each subject cannot be measured, but this could be a possible factor that affected the results of the tests.
We assessed the validity of all three of our tests. The validity of a test indicates that the test measures what it is supposed to. To measure validity, it is important to determine a criterion reference and to assess which participants are trained and untrained. For the step test, in order to be considered trained, the students must participate in 4 or more hours of aerobic exercise per week. We determined a criterion reference based on the norms of the YMCA 3-minute step test. We used the 50th percentile for both females and males to determine who's a master and who's a non-master. Females had a criterion score of 112 beats per minute, and males had a criterion score of 102 beats per minute. We used a contingency table to look at our results. To determine the validity coefficient, we added the values from the 2 boxes where we expected the most results. There are 9 trained masters and 4 untrained non-masters. Our validity coefficient was 0.542, which means that the test is invalid. Studies show that adjusting the bench height to the participant's leg length could enhance the validity of the step test. We use the same trained and untrained criteria for globe jumps as we did for the step test because they are both measuring cardiorespiratory fitness. We did not have norms to compare our results to, so we used the mean of the scores as a criterion reference. The criterion score was 138 beats per minute. 6 participants were trained masters and 7 were untrained non-masters. After adding up the values from the expected boxes, we got a validity of 0.54. This again is an invalid test. For the Walsett test, we measured both validity and reliability. Walsetts measure muscular endurance, so we looked at the students' participation in strength training per week to determine who was considered trained and untrained. To be considered trained, the students must participate in more than 2 hours of strength training per week. We used the mean of the best scores to determine who was a master and who was a non-master. The criterion score is a time of 81 seconds. There are 7 trained masters and 9 untrained non-masters. Our validity coefficient was 0.666, making this the most valid test that we performed. We use the same criterion reference for masters and non-masters when determining reliability. Reliability is the consistency of a test given more than once, and it compares masters and non-masters for both trials. We first determined the proportion of agreement by adding the 2 percentages of those classified the same on both occasions. Our proportion of agreement was 0.749. We then determined the proportion by chance, which was 0.5859. Using those, we were able to determine the kappa coefficient. Our kappa coefficient was 0.3938, showing that our test was unreliable. Because it was unreliable, our Walsett test can also be classified as invalid. We conducted a t-test to see if there was a significant difference between the 2 trials of the Walsett test. It was a dependent t-test because we compared the same group at 2 different points in time. We expected the second trial to have a significantly lower average due to muscle fatigue. Our t statistic was 0.451. After looking at the critical value on a t-test significance table, we found that it was 2.021. For our test to be considered significant, our t-statistic must be greater than the critical value. Since 0.451 is lower than 2.021, there is no significant difference between the trials. The bar graph represents the average scores for each trial in the Walsett test. Trial 1 had a slightly higher average, but according to the t-test, it was not a significant difference.
The results of the STEP test, globe jumps, and Walsetts justify the following conclusions. All three tests were proven invalid and the Walsetts were also unreliable. We did not find any correlation between the two tests that measured cardiorespiratory fitness. The Pearson correlation demonstrated the lower limb muscular endurance has a low correlation to cardiorespiratory fitness. The table to the left shows the YMCA beats per minute normal rankings. The rankings differ between male and female, but both range from excellent to very poor. The graph to the right shows the students in our KINS 369 class being ranked into each category, blue for male, red for female. This graph shows an assumed distribution as the majority of the students fell into the middle categories, from good to poor, as only a few students fell into the extreme categories, excellent and very poor. We had several sources of error: inconsistent effort expended by participants, an inconsistent time interval in between trials for Walsetts, uncontrolled environment, unorganized, 4 different administrators measuring heart rate for 30 seconds instead of 1 minute. Using a 30-second interval would have had a higher recovery heart rate compared to a 1-minute interval, therefore underestimating the cardiorespiratory fitness level of the individual. Subjects performed multiple Walsetts on the day of testing, causing potential fatigue. When calculating the validity and reliability for the Walsett test, we do not take into consideration the differences in gender. Studies suggest that males have greater muscle and aerobic endurance. If we based our criterion on the differences of gender, this could have affected our results. And lastly, our globe jump test was not objective because there was not an established method for administering the test. Even though we didn't get the expected results, we believe that with more practice and improvements on protocol administration, these tests would be a good indicator of muscular endurance and cardiorespiratory fitness.